Okay, in the last video we had gotten into this problem, number 59 of section 2.3, and we had found that the tangent line should be negative 6.93 times x plus b, and our b was 0.628, and we also knew that the function itself was 1 plus cosecant of x over 1 minus cosecant of x. The point at which the tangent line intersected the function was pi over 6 comma negative 3. So what we're going to do is we're going to go online. All right. So there's a couple different graphing calculators that you can use, www.google.com. And I say online graphing calculator. I don't even need to type it in anymore. Google makes it easy for me to be lazy, so I can just click it. There's a cool math one. That one's pretty cool, right? They give you a x min range, an x max range, a y min range, and a y max range. And so in this particular one, so if I were to type in x squared and hit enter, it would give me the graph of x squared, and I can change what the window looks like by just changing these values and then pressing the enter button, and it'll change the window for me, right? I don't think that I can put in a scale here. It just kind of makes it 1 no matter what. The one that I'm going to show you is the one that I kind of like, this GCalc, the online graphing calculator. There's a GCalc 2 and a GCalc 3. I think that the GCalc 3 is, well, it's not very good. The GCalc 2 seems to be pretty good. So you don't close this one little window, and you have yourself a free online graphing calculator. Okay, so alright, we want a nice little window around our function. So our x value that should be pretty much the center is pi over 6. And if we put pi over 6 into our calculator, so divide pi over 6, I'm using my TI-83. Unfortunately, I don't have one of those little simulators to show you, but maybe I'll get one in the future. It says that it's a 0.5235 something, so just about a half. So if we make our x min of 0 and our x max of 1, that'll put 1/2 pretty much right in the center of the window. So we'll use maybe an x scale of 0.1 so we can see it. So there'll be 10 little divisions on the bottom. How about a y min and a y max? Well, the point that they give us for the y value was negative 3. So maybe let's go from 0 to negative 5. Oh, so that means that my y min will have to go be negative 5. My y max will be 0. And I hit enter, and it kind of gives me a nice little scale right here. Okay, so the really easy part about this is that I can put it directly into the graphing part, right, or the function, excuse me. I can define it, and we said it was 1 plus, and I don't have to mess around with sines and cosines to try and define them like I might have to do on my TI, though I love my TI. I can just type CSC of x. So that's cosecant of x, and it actually knows what that is. And then that's going to be divided by 1 minus cosecant of x. If I hit enter, hey, it plots it. Cool. All right, so now I got to look at this, right? Let's see. So then the other part was, right, negative 6.93. Negative 6.93. So this is my tangent line now. Plus 0.628. That's right here. And then I hit enter. And is this negative 3? Well, I get little coordinates down here at the bottom. It's just about in the center of the window, 0.522 and negative 0.3, roughly, negative 3. The other thing that we can do is we can make a horizontal line at negative 3 and make sure that it should cross right at the point of the function, and the tangent line should be there. And I think that pretty much confirms it. We have a tangent line that intersects the function right at the point that is illustrated in the problem. I can even, if I click and hold, click this point and drag around it, I can press this little square zoom. Oop, let me zoom out. Zoom out, zoom out, zoom out. Oop, zoom in. Square zoom in on, oh, that's because it made it. Let's see, maybe box zoom, that's what I want. Box zoom in on this. And the tangent line is a very, very good approximation of the function right in and around that point. It shares the inflection of the function, so it has the very almost exactly the same rate of change, right, in and around a very small area right around our point. So that points to the fact that, hey, it looks very much so that this is indeed our tangent line, and we correctly calculated the derivative and correctly calculated the value of our tangent line there. So that's it. So that's the problem, and now you know a little bit more about this online graphing calculator, which is free. Oh, speaking of free software, if you're curious about what I'm using to record all this stuff, this is a thing called Cam Studio, and it records the AVI files, and it's nice, and you can make little recordings for yourself and, you know, help out other students or whatnot. GCalc, hey, that's free as well. And Smooth Draw 3, which that's also free. So all this stuff is free, and you can get it. It's open source, right? The benefit of programmers helping programmers. Okay, that's this problem. So next problem, we'll do something else.